It's called operations research, or optimization, figuring out the fastest way to complete a task. It got its start in 1840 after Charles Babbage, the father of the computer, helped the British Postal Service figure out the most efficient way to deliver mail. Back then, scientists used slide rules to solve these kinds of problems. Today, they use supercomputers. So you would think it would be pretty easy to come up with a solution. Well, it turns out that problems like this are still way too big for even the fastest computers. For example, what is the most efficient way to deliver 16 million packages a day? That's the problem that Jack Levis and his team at UPS are trying to solve. To understand what they're up against, let's pretend I have an Aunt Gertie, and I want to send a package to her. Its journey begins in San Francisco, Tuesday night at 8 p.m. By 2 a.m. Wednesday morning, it lands in Philadelphia, only 140 miles from Aunt Gertie. 7 a.m., it arrives here at the UPS shipping center in Gettysburg, Pennsylvania. It's already traveled over 2,500 miles in less than 12 hours. It would seem like the hard part's done. But, as I found out, it's just the beginning. Once it's on the truck, figuring out the fastest way to get it the final 4 miles to Aunt Gertie's, that's the real challenge. To do that, you have to solve a very difficult and complex math problem.
Traveling salesman problem.
Traveling salesman problem?
The traveling salesman problem.
What's that?
It poses the question of what's the most efficient way to visit locations, just like a traveling salesman used to have to figure out.
Simple, right? Turns out that this problem has vexed generations of mathematicians.
Let's say you have an office on Main Street, and you have 3 customers. One's on Elm, one's on High, and one's on Maple. You know the time and distance between them. Well, what's the most efficient way to visit these customers?
So, Elm High Maple, that's 1. Maple High Elm, that's 2. High Elm Maple, 3. High Maple Elm, 4. 4.
Well, there's 6. You know how I know there's 6?
How?
With 3 customers, it's 3 times 2 times 1. There's 6 ways. If you double that to 6 customers, now there's 720 ways. At 12 customers, there's 479 million ways. If you had 25 locations to go through, there's 15.5 trillion different ways to visit 25 locations.
Trillion? So, if a 25-stop route has trillions and trillions of possible combinations, imagine how many possibilities there are in the 140-stop route that will take my package to Aunt Gertie.
There's not even a number to articulate this. There's more ways to deliver this route than the number of nanoseconds the Earth has been in existence.
So if the traveling salesman problem is too tough for the world's largest computer, how do you solve it? By building a smarter program. It's called Orion. How does it actually calculate the route?
Well, it's going to start with something that's just very simplistic. It's not going to think like you thinking ahead. It's going to say, who's my nearest neighbor? So it's going to start at the beginning. What's closest to me? And it might go to the next stop closest. So when it's done in its very first iteration, it's created a route that looks like a kindergartner would have created. And then it says, now what's wrong with that?
In this case, it does that by breaking the task down into sets of smaller problems, each with 5 variables with 120 possible solutions. The first step is starting with clusters of 5 stops and figuring out the most efficient way to deliver packages within that cluster. It arranges them into larger groups of 5 and figures out the most efficient way to move between them. Finally, it connects them all together and arrives at a solution with only thousands of calculations total. And it does all this in a few seconds. But that's just the start.
We have 8:30s, we got 10:30s, we got noons, we have...
Deliveries promised by a certain time. Throw those into the mix, and it makes finding a solution nearly infinitely more difficult.
Now you try to do that on your own and think of the number of combinations you would have to think through.
Now here's the thing. Orion is not looking for the perfect solution. It's looking for an optimal solution that can be figured out in a few seconds. The question, is this better than what a human without a time limit could come up with? With human pride on the line, I decided to pit man versus machine and see if I could come up with a quicker way to get to Aunt Gertie's house.
And home.
All right, so how do I compare with Orion?
The only way to know is to give it a try. You ready to brown up?
Excuse me? Before I do my own route, I have to do a little boot camp.
Permission to come aboard, sir.
Yes, sir.
I ride with veteran driver Tim on.
I've done it for close to 10 years.
Tim says it's not just about planning the fastest route. It's about how fast
UPS.
you can get that route done.
Perpetual motion.
Multitasking.
Okay, I gotta move along here.
Ever deliver a baby or...
I've never done that.
I'm ready to put my traveling salesman solution to the test.
You got 4 next day air packages that got to be done by 10:30. This one by 3 p.m. You got business customers that need to be delivered earlier part of the day.
Okay.
Pickups. They can set their watch by the time we get there. Good luck. That's logistics, buddy.
The challenge here, me driving my route and Tim driving Orion's.
UPS!
It's 10:30. Tim's completed 28 stops, which is pretty good.
UPS!
David's only got 21 stops off by now. 12:30, Tim's got 48 stops done and he's on lunch. David's actually catching up. He's gotten 54 stops done by now, but he hasn't even taken his break. He's got to start that hour break right now.
UPS.
It's 2:30 and you know, they're neck and neck right now. Tim's delivered 73 stops and David's at stop 74. So they're neck and neck, but David still has some businesses he hasn't delivered yet. 4:30, Tim's now moving well ahead of David.
UPS!
You know, those businesses are going to close in the next hour. It's 6:28 and Tim is back in the building. David's got 10 more stops to do.
Surprise!
Oh my gosh, what have you been up to? Oh my goodness, it looks exactly like you.
Oh, thank you.
I love it. It's been such a long time.
Yes, it has. Now, could you just please sign here? Great. See you.
You bet.
It's 7:04. David's just now coming in, 25 or 30 minutes later than Tim. We got to talk. For a first-timer looking as a crow-fly solution, it's really pretty good. But you are about 10 miles over our Orion solution. If every driver just drove 1 additional mile per day, after a year, that'd be $30 million. So 10 miles for us
$300 million.
is a lot.
That would have been an expensive...
And it only gets worse. My route took 39 minutes longer than Orion's to complete. Company-wide, that would be a loss of millions of hours a year.
We'd be out of business. I'm sorry, Dave, but I need the Browns back.
You're firing me?
Well, I had a good run, but I was no match for Orion. With a plan that would, at best, bankrupt one of the largest shipping companies in the world, it was time for me to move on. From getting packages there on the ground to getting people there by air, these kinds of problems are